functions of several variables, 6.1. So originally, we are used to see f of x equals something. So that means they give you a function that has one variable called x, one variable x. So if you wanted to find, let's say f of x is 2x plus 3, and you wanted to find f of 5. So you would do 2 times 5, replace x with 5, plus 3. That's a 10 plus 3, which is 13. So 5 is called the input, and what we got is called the output. It's called the output. So here in this function, in this section, remember it says several variables. So it's not going to be just x. You can have more than one variable. Say you have x, y. This means there are two variables, x and y. This is x squared minus, let's say, 6xy minus y squared. So that's a function in two variables, x and y. They can ask you to compute, let's say, f of 2, 0. And f of -2, -1. So to find f of 2, 0, all we have to do is substitute x2, y0. So x2, and y0 minus 0 squared. And what does that give us? 4 minus 0 minus 0, so it's 4. Similarly, f of -2, -1. Try this one. Okay, so to evaluate this, what do we get? We substitute x with -2 square, -2, y is -1, -1 square. So that gives 4 minus 12 minus 1, -9. That was for these two variables. Let's take a look at another example. Let's say g of x, y. It doesn't have to be always f. Natural log of x plus y cubed. And compute f of e to the 6 comma 12. So for this one, oh sorry, that should be g, not f. We're used to write f. G of e to the 6 comma 12. Natural log e to the 6 plus 12 to the 3rd. To the 3rd. So what do I do with this? You can bring the 6 down, natural log of e, plus 12 to the 3rd, it's 1728. Natural log of e is 1, so 6 plus 1728. That would give us 1734. So you can have exponentials, logs, anything. Another example, can that go beyond that? Can we have more than two variables? Yes, let's say I want to do x, y, z. 6x minus 9y squared plus 5x cubed minus 8. And they ask us to compute f of -1, 8z plus 1, comma, -3. So we find that by replacing x with -1, y with 1, and z with -3. 6 times -1, 1 square, x is -1, z is -3, plus 1. Then -6 minus 9 minus 5 plus 24. This is -15 minus 5, -20, plus 24 plus 1. That's a 4 plus 1, and that gives us 5. That's how we evaluate functions with more than one variable. One other thing in this section to learn is how to find domain for two variable functions. So how you find domain. Now, when it comes to finding domains for something like this, we have to watch carefully. We're not going to go in depth with this part or topic as we teach it in multivariable calculus. So what we do is to find the domain. I'm not going to interpret it using geometry because it's a lot of work for you. So it's just how to find domain in general for multi functions like this. So let's say we have, or we're given f of x, y equals, fxy equals, let's say x cubed plus y cubed. We need to find the domain. Or something like f of xy, the square root of 4 minus x squared minus y squared. So to find the domain for the first one means what are the x and the y values you're allowed to substitute into the first function. Can I substitute zeros? Can I substitute negatives, positive? Yes, you can. You can substitute anything you like in here. So you can substitute anything for x and anything for y. So we can write it this way. X can go from negative into infinity and y can go from negative into infinity. So domain for this would be all real numbers. All real numbers for x and y. It can be any numbers. But for the next example, we have to take that quantity under the radical and make sure that quantity is non-negative, because the square root doesn't take negative values. It can take 0 or more. Now, how do we solve this equation, inequality? We can subtract 4 on both sides. And if you multiply by negative, you swap the inequality sign. So when we find the domain, when we write the domain, we write like this, braces x, y, and then we put a slash. That slash means such that x squared plus y squared is less than or equal to 4. x squared plus y squared is less than or equal to 4. So now, if we look at another example, fxy is 7 over 6y minus 9x squared. Can I put any values for x here? Well, I can put any values of x as long as I don't make the denominator 0. So for example, x equals 0 and y 0, they do not work out. You cannot have both zeros. So this means we have to eliminate some of the values. But how do I know all the values that I must eliminate? Well, the way it goes is you need to make sure that the denominator cannot be 0. So you can add 9x squared. If you divide by 6, which can be reduced to 3/2 if you divide by 3, so this means the domain can be written as xy, always xy like this, always such that y cannot be 3/2 x squared. One other one here, 1 over 1 y plus x squared. Try finding the domain for this one. So let's look at this one here. For the domain, you need to make sure that the denominator cannot be 0. So if you subtract x squared on both sides, y cannot equal negative x squared. So the domain is going to be all the xy values such that y cannot be negative x squared. Y cannot be negative x squared.